So here we have the curves for the functions both r equals 1 plus 2 sine theta, shown in black, and r equals 4 sine theta, shown in red. This function here, r equals 1 plus 2 sine theta, is what's known as a limison, which has the function a plus or minus b sine theta, or a plus or minus b cos theta. The size of this inner loop that you can see in the center is determined by the ratio between a and b. The larger the ratio, the bigger the inner loop. When a and b are equal, there will be no inner loop. It will just come to the point here in the center. R equals 4 sine theta is what we found in the first question of the workshop, which is just a big circle with center point 0,2, which is right here. It has a radius of 2, which means it ends up at y equals 4. This is all on a polar grid.
So first we'll go about solving that. So 1 plus 2 sine theta equals 0. You'll get 2 sine theta equals minus 1. And sine theta will be minus a half. Solving for theta, you'll get values of minus pi on 6, pi on 6 plus pi, and so on, which will be minus pi on 6, 7 pi on 6, so that's continued, on 6, 11 pi on 6, and 19 pi on 6. So just looking at so just knowing what quadrants it's in, because so from minus pi on 6 you'll get in this quadrant and this quadrant. So yeah, that's how you get that. Solving for so you're going to find out where essentially r is negative. So looking between minus pi on 6 and 7 pi on 6, so you'll end up with theta equals 0 and r will equal 1, which is not negative, so it can't be between there. Looking at theta equals 3 pi on 2, which is between 7 pi on 6 and 11 pi on 6, you'll get a value, so if you sub that in, 2 sine 3 pi on 2, that equals negative 1, which is negative, and therefore theta is between 7 pi on 6 and 11 pi on 6.
So for part B, we want to find where these two functions cross the x and y axes. So what we're going to do is we're going to find the values for where they're going to be on the axes. So for the y-axis, we've got pi on 2 and 3 pi on 2, because that's the degree. And for the x-axis, we've got 0 and pi. And then we can also test the origin when r is 0, because obviously the origin across the axes. So here are our test points. We've got r0, theta 0, theta is pi on 2, theta is pi, and theta is 3 pi on 2. So we take these values and we plug them into our functions. So for our first function, we've gotten these 5 points, and for this one, we've got these 5. And they're our points where they cross the axis.
Firstly, we just make these two polar curve equal, like 1 plus 2 sine theta equals 4 sine theta. Then we get sine theta equals 1 on 2. Because sine theta equals 1 on 2, and then we can get the theta as equals pi on 6. or pi on 6, pi minus pi on 6, then 2 pi minus pi on 6, blah blah blah. So as the picture requires, we just make it 2 equals 0 to 2 pi. So then we have 0 equals pi on 6 and pi minus pi on 6, which is 5 pi on 6. So when theta equals pi on 6, we have the r equals 1 plus 2 times 1 on 2, so that will give us 2. So now we have the 2 points. Also for the 5 pi on 6, we also get r equals 2. So now we get 2 points as for the intersection as the 2 of 6 on pi and the 2, pi on 6 and 5 pi on 6. That's the final answer.